Hey everyone, this is your weekly episode of the Zephyr podcast, where we talk about all things Zephyr, embedded, open source, lots of other cool stuff. I'm Benjamin, your co-host.
I'm Fabio, your other co-host. We are at FOSDEM.
In the flesh.
Yeah,
You sound good. You should sound better than you usually do. I hope. Better, Mike.
At least we should sound the same. Anyway, we're not actually at FOSDEM. We're in a hotel room in Brussels. FOSDEM is tomorrow, but close enough.
Yeah, well, and I mean the festivities already started earlier today, this Friday, January the 30th. There was a really nice meetup actually in Brussels downtown, organized by the folks from Mind. I think the talks were recorded, so should be available online. Really,
Some of them at least.
yeah, some of them. But I mean, the setup was good, and there were quite a few interesting talks. I mean, we might be biased.
Oh yeah, because we gave half of them. Yeah, anyway, what a good turnout. Few people, good question. Yeah, great stuff. I guess we'll talk about some of them.
Yeah, we can talk a bit more about this. What happened this week in Zephyr?
The project doesn't stop. A few things actually. So I've seen a few warnings in the pull request. I suspect you have something to do with it, Benjamin.
Yeah, more CI. I think we mentioned it maybe a couple weeks ago.
You've been warned.
Yeah, but I'm actually quite happy about how this turned out. The Oxygen guidelines are in place, and now when people introduce new APIs, new symbols in public headers, they have to be documented. And yeah, the CI is, as far as I've seen, is working as it should, and so flagging things that are missing. And I've seen people just being like, "Oh yeah, sure, I forgot. Let me fix it." And yeah, I'm really hopeful that this will help increase coverage and like I think we discussed in previous weeks, like it's now mostly the machine that does the job of pointing people at things that don't necessarily fully follow our guidelines, and yeah, people will be complying more.
So explain me something. I've seen that sometimes it adds the message as a warning and sometimes as an error. Is it like new file, existing file?
Yeah, it's kind of it's a challenge to make it not too intrusive for people. So the way it works right now is that when it is a public header, as in, I don't know, you're introducing a new driver or new public API on a driver, this has to be documented. There's no way around that. If you don't, it's going to be an error. It's not going to block your PR though, but at least it's going to show in red, as in, yeah, please do fix it. It might only show up as a warning if it's something like a header for like device tree headers. And so like headers for, yeah, stuff that's usually automatically generated and or really self-described. Like I don't want to impose that people put comments on those, so it will only show up as a warning. But in any case, it's not blocking the PR. I shouldn't say that. Maybe because to go up and ignore it.
Yeah. Yeah, I mean, if there's an existing file that has a list of defines and the pull request is just adding a couple of them, you don't want to get in the situation where you have to ask the author to change the entire file to make it compliant. So I think it's implementing in the right way. But if the definitions are meant to be internal, I guess this is a good way of catching the situation, and the file should have the necessary guards to make the file.
Yeah. Sometimes it's actually, doing, initially you would be like, oh, why is it asking me to document like 40 things? Oh, well, but maybe I shouldn't put them as public APIs in the first place. And so, yeah, there's, I mean, just go and read the guidelines. It should be pretty well explained when you should put a symbol behind those guards that make it clear that, yes, they are part of the public header, but they are just there because like some drivers use them like internally to Zephyr code and shouldn't be consumed by the public.
Either way, the warnings are automated, so at least you get fast turnaround when you do changes. You don't have to wait for a human reviewer to drop you a comment and tell us if you're doing things right or wrong. So I think it's good. How hard is it to run it locally?
It's reasonably easy. There's a bunch of make targets that are there. Like getting the effectively the Doxygen coverage report is really trivial. Just make Doxygen coverage from the doc folder in Zephyr. Getting the Delta report like CI does, I guess this should be documented somewhere. It might require you playing a bit with your Git work trees and stuff. So I'll look into making it easier, possibly. But generally speaking, generating Doxygen and or Doxygen coverage report at a given point in time, that is all there.
Good job.
Yeah, more documentation. It's always and again, like, it's really nice to see the community just embracing the fact that I mean, we're Zephyr. We are not a random GitHub project where it's like go and read the code and go figure. We try and document what should be documented.
So you say the community embracing the effort. I can imagine the listener going like, "Oh, jeez, I have to do documentation for every line now."
Yeah.
Like, yeah, we embraced it. Thank you.
Yeah.
Great stuff. Is CMake fast enough?
Yeah, it's interesting to see more and more people spending time, like some of the recent pull requests are people trying to help us sort of address the technical debt that we have in some areas in Zephyr. And some of those areas it's not Zephyr proper. It's not like it's everything that we have around it. Like West can be optimized, I'm sure, in many ways. Our build system can be optimized in many ways. And people are doing the smart things. They are using profiling tools and things like Perfetto, like we mentioned a couple times in the past, to trace our CMake build process. And I think this week we merged a new PR where, supposedly somewhere in the way snippets are parsed in Zephyr. It was suboptimal. And
so this was optimized parsing performance. It's really cool. So if you look at the pull request, it opened this is how a pull request should be. It opened with the command line that has been used to generate the profiling data. So if you're interested, if you don't know how to do it, you can use this as a reference and figure out how it's been done and how can you do it locally and reproduce it locally. And then it had a screenshot of the graph for the profiling data for the run before and after the optimization, and obviously the change for the optimization. So first thing is really cool to see people micro-optimizing things that are not strictly RTOS, right? Like you think that the contributor of the project are only interested in doing firmware proper level code, but with a community this big, you're gonna find the person that has knowledge on how to optimize the stuff that are peripheral to the project. And this was one of them. Thanks to this, we've now have a faster build it.
And in this case specifically, I mean, I don't think you did it on purpose, but I wouldn't call it a micro optimization. Like effectively saving a couple 100 milliseconds on build time, which is usually maybe a couple seconds. I mean, that's significant chunk.
Yeah, especially if you're doing it like on CI and you may have hundreds of build. I was mentioning today the weekly build that we have, which does, what is it, 100,000 builds?
Half a million tests or something.
So it adds up.
Yeah. And the whatever number, again, it's saving a couple 100 milliseconds, but that's when you're building Zephyr upstream. But like, I could easily imagine for this optimization, folks that have a lot of custom snippets downstream, this might actually mean even more optimization for them, because usually we see those parts of the build system, like the more snippets you have, the more boards you have, the slower the build gets, and any optimization matters even more. So really cool stuff.
I'm surprised you can use the Perfetto tool for profiling the build system, but then CMake, you could probably build your operating system in CMake. So.
Yeah, it does a lot.
Makes sense.
It makes sense.
Oh my God. Yeah, all right. So
news from the architecture working group, maybe?
Somebody once said that 640 kilobytes should be enough for everyone. Some other people said that 127 characters should be enough for everyone.
There was an interesting discussion, right? Earlier this week.
Yeah.
I mean, this was brought up in the architecture working group. It could have been brought up maybe in other forums, but the discussion was around what should we do in Zephyr, should we allow anything that's not ASCII characters?
In the documentation specifically.
Yeah, and specifically for documentation, I guess, but we could probably have the discussion for the code too.
Because I tried to limit it on the code and failed.
Yeah, it's a challenge. And like, even if you look at other big open source projects, Linux to name it, like it kind of feels like they gave up. Like in some areas, you would see like degrees Celsius Unicode character, or like the micro sign as Unicode that's actually part of the source code. I mean, in some areas, it's fine. And so again, specifically for documentation, the discussion was around what should we do? Because for people familiar with it in Zephyr, historically, the guidelines are, no non-ASCII characters. If you want to put copyright, there's like a funky substitution that you could use, that you should use. Except that, I think we're in 2026, and for documentation where you want good typography and you want to use what's out there beyond those 1 in 27 characters.
So we have a guideline right now that says that you should be limited to ASCII for the documentation. That was my understanding.
Yeah, we do.
But we don't have a guideline that says you should be limited on the code.
I guess we don't. Yeah.
Like, you would imagine the opposite to be true, right? Like, I would care about the code to be limited on ASCII, especially the strings, right? The comments I don't care that much about, but stuff that gets printed on a console or an error message.
Yeah, stuff for which you want like strlen to behave in a predictable way, sort of.
Because the thing I have in mind is, in our case, we log some of the stuff, some of the messages they pass through a different system in our CI, and sometimes when you get the log, you see the control character for the shell, for instance, and those get printed, they become noise in the print. So I don't know, not think about what's going to happen if you have a UTF character. They may work actually, but it's weird.
Yeah, starting with the documentation, at least, I think there's an agreement that for documentation, let's just use whatever. Let's not go crazy though. Like, I mean, probably don't want to have like emojis, etc., but anything that makes sense. And there's actually a PR out there already to replace all those old school substitution with plain Unicode characters. And I've added a couple guidelines to be like, hey, use whatever makes sense typographically or whatever helps make the thing more readable, but just don't add emojis for the sake of it.
Yes, please.
Although you could.
Yeah. I can tell you what happened with the code. So at some point, some emoji is nicked in some shell log messages. So we got rid of them. But then I did this CI check, try and limit the old C code file to ASCII. And then I tried to bring the code base in compliance and quickly realized that was not going to happen. So then I also checked what Linux was doing, and they were not doing it either. Basically, it would have been a massive effort of both bringing existing code in compliance, but also adding an allow list of characters that we would be fine with. And the micro thing is very popular in the sensor subsystem, and it looks nice. What can I say? So we ended up adding only a guideline like you should use ASCII. Please don't use emojis. But
yep. Progress on the documentation front, at least. Another interesting discussion from the architecture working group is about all things motor control with hard real-time constraints. Like, did you have anything to share about this one?
Yeah, so this was about FOC, which is a fancy way of controlling motors, like doing a position and speed control, stuff like that.
Can I ask what FOC stands for?
Field-oriented control, I think it means.
Okay.
This is not quite my field, pun intended, but yeah, it's one of the ways apparently of doing a feedback loop on a motor controller. You may want to control the position or the speed, and there's various ways of doing it. But I think that the interesting part of the conversation in the architecture working group was that they're trying to build a subsystem and an API for this, but this is a more complex piece of infrastructure. So it's going to reuse other subsystem, other parts that have an existing subsystem. So the question was whether it makes sense to build on top of the existing subsystem, extending them for the extra functionality that they need and eat up the overhead, or do a custom driver, essentially having some duplication, but having a more optimized thing. And the consensus seems to be that you have to go for a unified design. They have a fancy, they call it a unified inverter driver. Fancy. It seems to make sense, right? It's a topic that comes up every now and then. When we talked about Lean last week, there was a similar conversation in the architecture working group, because some of the Lean transceiver are implemented with an extension of the in the same silicon as the UART controller with an extra encoder. So the question was, do we extend the UART API, or do we have a dedicated driver? And I think the direction we're going is to have a dedicated driver. But it's also not quite a new thing, because in many system on chip, they have shared silicon for stuff like UART, I2C, and SPI, because the devices are somewhat similar. So in the Nordic chip, for example, you have this module that can do either I2C or SPI. It's a bit tricky, because when you design your system, it may, like, if you don't know well enough the architecture, you may think you have 3 SPI and 3 UART, but you don't. But yeah, anyway, there are different drivers in the respective subsystem that use the same silicon in different ways. So I think this is the way to go. Interesting design. It's cool to have this stuff in the RTOS. Looking forward to it.
Yeah, what was great as well is this is one of those RFCs where the C's are really happening. Like people, this is a request for comments, and both offline on the pull request and in the meeting, people are chiming in and like sharing their experience, their use case. So yeah, it's really good progress on this one.
A lot of people are like, "Hey, I worked on this before. This is what I know," which is super cool. Yeah, I didn't say a word.
I think John chimed in. It was like new name, new face, really cool. More acronyms, I guess. FDB. What is FDB?
FDB, we're talking about switch Ethernet bridges, also known as switches. Zephyr is a fairly healthy network stack. There's few things that are fairly advanced for being an RTOS. One of those is there is a bridge driver. You can add multiple Ethernet interfaces and set up a bridge between them so that packets are forwarded. This is FTP is the forward database. It's a fancy name. It's just a list of the MAC address that are seen by the bridge in the various interfaces, and it's used for forwarding packets. And there are corresponding shell command for adding and removing them. There's quite a bit of code for the bridge stuff. There's a whole distributed switch architecture thing, which I'm not very familiar with, but it looks like the RTOS is meant to be used, and evidently it's used as a base for some switch, I guess. The pull request mentioned that there's going to be support for hardware forwarding tables. For now, it's just the software one. I'm curious to see what's going to happen with this one, mainly because I did play, like, as it happens, I was playing with the bridge driver myself a couple of weeks ago. I took 2 boards that I have, and I tried to instantiate on one side the USB ECM, I think it's called, driver, and on the other side a real Ethernet interface, and bridge them. And I thought, I'm gonna make a USB Ethernet device, and I was expecting everything to work and be beautiful and rainbows and unicorns. That was not the case. I don't know, I didn't quite work out. I had a few errors on the USB side, a lot of warning on the console. I need to pick it up again, because, like, I'm sure this is tested in CI. This obviously works at least with the native SIM driver. I need to see what is wrong. But this is a cool part of the RTOS that is maybe not as popular, because it's a bit of a niche. There's not that many SoC with multiple Ethernet interfaces, but I like networking stuff. I want to explore more of this.
Yeah, and this one PR is coming from NXP, and I'm really seeing a lot from NXP these days. I'm actually wondering, like, what we discussed just before about the motor control. I think this might also be coming from NXP. I'm not sure. But yeah, networking stack, like you said, is really. I don't know if you said that it's decent or like that it is actually really, really good.
There's a lot.
Yeah, and one thing that always amazes me, back to documentation on one hand and testing on the other, it's like they have 100% coverage of everything. Like documentation of the API is like perfect, and same for test coverage. Like if you look at the CoAP stack and MQTT and DNSSD and whatever, like you have tests that have like 100% coverage of all the code paths.
Yeah,
Pretty
yeah,
much.
yeah, that is good. I was working on a PoE device recently, and I thought I had to use LLCP for the negotiation, and looked it up, and there's a small stack for LLCP. There's a sample as well. I was like, who did this?
Yep. And it's like, it's also like a great way to do sometimes some archaeology or some history of the internet, because you can be like, oh, let's look at what's the RFC behind this particular, and you can like do lots of like really interesting reading. Yep. I like it too. Something that got merged, it's really just an FYI, but this might be useful and interesting for folks. It took a while to get this in good shape and merged, but the counter subsystem and the counter API now supports 64-bit resolution and 64-bit counters, so you can like set alarms, etc., for up to 64-bit if the hardware supports it. But and it's something that you can optionally opt in, like even if the hardware support it, but you don't want to like get the overhead and you want to stick to 32 bits, that's also an option. So yeah, just got merged. What else?
Haha, catch me a surprise. So this was merged recently. One thing you usually do not do on an SoC is go out of spec. So you really tend to not overclock them.
Really? Is that the thing? Because I remember, I mean,
Usually want your stuff to work.
yeah, because interestingly, so I mean, some people might remember in the a few years back, I did those like tiny ML experiments with the Wio terminal from
Yeah.
Seed Studio, and what always like amazed me with this one is that like by default, even if you use the Arduino IDE to program it, it is effectively overclocked. It's a SAMD 51 something.
Brilliant.
And they overclock it for, yeah, I don't know, like for DSP and for neural network stuff. It is effectively overclocked.
Well,
So maybe it's a thing after all.
yeah, I mean, our contributor, Vindragon, certainly think it's a good idea. His email is from massdriver.space. Like, I don't know, they probably have some reliability requirement for the stuff. I presume he's not sending this stuff to space anyway. So he submitted a pull request for doing some tweaks, some variation of one of the Buffalo Lab board. What I think is funny is that he added some config that are like overclock and overclock unsafe. I want to know.
Yeah, so
after the safe overclock and the unsafe overclock is gonna catch on fire.
yeah, and it feels like overclock as in how one would do it on PCs. Like it's not just like changing the clock, it's also playing like in parallel. You want to play with the voltage to get better stability and whatnot. So it's interesting.
You also said when overclocking, DMA and DMA using drivers will not work properly. It's really fun. Anyway, good job. That's a lot of work. He went as far as doing a bunch of benchmark and everything as a nice table of the result on the pull request.
Yeah, and just looking at the pull request, it's adding a lot, including a couple of device tree bindings. And I'm seeing a review. I don't know if you're catching it as well, Fabio, as you are looking through the PR. But one of the reviewers told Vindragon, "Hey, in your DT binding, you have the nice description for the Buffalo Lab power controller, blah blah blah. You have a really nice device tree snippet of an example of how one would use the binding in question. You should consider using the examples property." What I mean by that, it's something that we just recently added. I think Linux had it already, but in your device tree binding, in the YAML file that describes the binding, alongside the description and like a general description, which is free-form text, where historically you would put potentially some examples. Now there is a dedicated section, dedicated examples property, where you can put just the device tree binding. So like it's clearly identifiable. It renders nicely in the documentation online as well. And yeah, so it's there. I think most bindings in tree that had something that kind of looked like a device tree snippet was moved, but there might still be a few that need to be updated. And going forward, I guess it's a note to folks listening. Yeah, do use it. Like it makes your documentation look nicer. It makes people know where to look for samples.
But it's a good way of doing it, right? Like rather than reading the description and try to guess what you should do, this is meant to give you a working snippet of code that you can copy paste in your board. What I would normally do is try, like when I'm trying to use the device, is to look for a board that uses.
Yeah. You want to copy
But
paste
this is
and have a starting point.
this works equally well. Do we parse it right now?
Kind of. It's not like validated, or like CI won't complain if it's not valid device tree, but the documentation build might actually, because it's doing all the magic to do syntax highlighting when it renders in the docs. So it needs to be valid device tree. We could probably validate it in an even like better way.
Linux binding, which are an interesting thing, by the way. They also have examples. You can have multiple examples, and they are parsed. And they also have a fairly complex way of defining constraint. And the example are used to validate the constraints as well. This is something that we may pick it up, though it probably doesn't have that much value. The situation with Linux is that the binding is built as it is, so you can have invalid content, and it's gonna give, but the fact that it's invalid is gonna get detected in runtime. So they use the binding to add some constraint that can be detected at build time, like when you compile the binding itself. We don't need that because we can have the validation of that in the build since it all gets built together. But I think parsing it with DTC in CI may be worth it, because then you're
I guess I simply don't know. We might need to, like, strictly speaking, I guess they're not valid device tree. Like it's missing the whatever is the first line that you typically have.
In Linux, you have to make them valid. You have to have all the includes and everything.
Like DTC version V1 something. Like there's always this first line which I don't remember off the top of my head. But yeah, like as always, people please do chime in on Discord or on GitHub, like if you have ideas on how to improve this even further. Go ahead. Yeah, with that, back to FastDem, I guess. So again, we were in the same room, probably headed for a couple of beers in a minute. But before that, what, like, anything you took away from the meetup, Fabio? Like what did you even talk about?
So I gave a bit of an overview of what happens in the release engineering team. Mainly I was trying to, it was like tip and tricks on like see what do we do and what you as a contributor can do to make our life a bit easier, and then we can make your life a bit easier. So it was a bit of a help me to help you situation.
And we didn't record it, and so we will have to find, like, we were chatting, like, yeah, we probably need to find some place where we have this FAQ of, I mean, we have some here and there, but
it was a bit of a brain dump of tribal knowledge on my side. But yeah, we got a couple of questions on the releases. I don't know, I think overall I got the impression that people are generally happy with the upstreaming situation process.
It was nice to see so lots of new faces at this meetup, including people doing presentations, and including people we were like, yeah, no, I'm like super early in my career, and I started to play with Zephyr and already did a couple of patches, and I was super happy with how it went. So it was it was nice to hear.
Yeah, you had a nice presentation. What do you talk about?
Yeah, something that we need to have more in the podcast, or maybe not, because we will have listeners. It was also a brain dump, and this one was actually recorded, and I will put the slides online. Kind of a brain dump of all things AI, LLMs, coding agents, how this can help or maybe not in the context of Zephyr. How, and basically talking from my own experience in terms of code reviews and writing better documentation, writing code, even like bringing up new boards, writing new drivers. What's out there? What's sort of like state of the art in terms of getting AI to help with code reviews? What are some of the caveats in terms of, I mean, copyright can be an issue. The impact on the environment can be an issue. So, I mean, I didn't answer all those questions necessarily, but this, I mean, yeah, there were tons of questions.
Yeah, and you gave a live demo.
Yeah, many like
To help you. You went right.
I think so. I mean, you tell me. I actually took many examples from the input subsystem, but yeah, a couple of demos of like how we can review code, whether you are the author and you want to polish the code before maybe upstreaming it, or whether you are an actual reviewer who's more responsible to make sure that this aligns with the coding standards in Zephyr. Yeah, did a bunch of demos of that, a bunch of demos of how you can take a data sheet, even like a random, not necessarily well-written one, take a data sheet and use it as an input to get help with the scaffolding of your driver, like get all those hardware registers, macros, and so on automatically generated, and actually most of the code even generated. Yeah, I think it went well. I was happy with it in the end. So
yeah, it was good. And you sent me some of the code while preparing for this, and I remember looking at the pull request and thinking, yeah, I know it's from Benjamin. He's cooking something with AI. But if it wasn't for that, I wouldn't have guessed that it was being done using some LLM, right? Which I guess, I don't know. What
is that good news or bad news?
So what I keep saying about this is that if I can tell that you used an LLM to generate the code, it's probably not good enough. But if I can tell, like, it's probably fine.
Yeah, and that was kind of like one of the takeaways, I think, from the presentation. It should really be just a tool, and the tool combined with your own experience of Zephyr and development in general, I mean, usually it should do something good. Like you use the tool, it spits something which is maybe 95% there. You help it and you do some human post-processing to get it to the extra 5% it needs, and then should be good enough. But yeah, recording, I guess, will show up online. Something else that was actually, I had no idea he was cooking and working on this, but Titouan, aka the Zephyr MIDI guy, I think it actually.
Yeah, that's his name now.
Yeah, that's
he needs to change his username.
That's him.
Zephyr MIDI.
But yeah, actually, his company was running and helping host the meetup. But he gave a quick update of where things are at around MIDI and Zephyr and things like that. And he mentioned something he's been working on. We will be dropping the link in the notes. A Z compose, basically a West command, more or less, that helps. When you do back to networking, you have like a bunch of Zephyr-based applications for, I don't know, like you have an HTTP server and a bunch of clients, or something that's more multicast setup for MIDI or whatever. Like you have different nodes for which you need to compile something. Like they all need to be compiled with addresses, and like they need to be part of the same network. You don't want to do that manually. Just like in Docker, when you set up, for those familiar with Docker, when you want to set up like a MySQL database with like a PHP server, like Apache, whatever, everything needs to be configured in sort of the same namespace. So decompose my understanding is that it was pretty much the same. And you then bring up your set of applications, you bring them up or down at the same time, and get some orchestration, I guess, this way.
Yeah, and he gave a demo, non-live. I think, yeah.
The demo is online on the GitHub repo. You can check it out too.
I like that he just pulled it off the head just like that in the end of the presentation. I was like, hey, I also did this thing. This could have been its own presentation.
Yeah, no, I really like it. Like even just the naming actually makes a lot of sense. Like decompose, just like you would use Docker compose. And like the syntax actually also feels sort of the same. You have this YAML file where you describe yeah, you have a MIDI server. I have 2 MIDI clients, and they share. I use the same variable to describe the endpoints and the ports and whatnot. So yeah, no, it's really cool stuff. I think he was mentioning or hinting at the fact that if people are interested, this could be upstreamed probably. So yeah, people do chime in. Like check out the Git repo, give it a try, a comment. And yeah, with that, I think just in general, comment, give us feedback whether we missed some PRs maybe this week that we're interesting to mention. Like if we forgot important stuff, tell us on Discord. Check out, as always, there's always a meetup near you. Like there was this one in Brussels this week, but there's a lot more. There's one in France that's coming up end of March, off the top of my head, in Rennes, and a bunch of others, pretty much on every continent as well. So check that out. And with that, I guess, yeah, let's see what FOSDEM has in store for us for the rest of the weekend.
Enjoy FOSDEM.
Yeah, and we will be back in a week. Take care, everyone.
Bye.